today, what I'll do, I thought of a different type of presentation. It was mostly going through some of the work we've covered over the last 2 or 3 years that really brings in how we can look at problems that we typically will see in some data science aspects, but then looking at them through the lens of natural language processing. So, so I'm at the University of Pretoria, and I'm the principal investigator for the Data Science for Social Impact Research Group at VP. Just in background, I went to Wits for my undergrad and master's in electrical engineering, then Rutgers for my PhD in computer science. I've worked at a number of companies as an intern, as a full-time employee, but right now I'm at the University of Pretoria as the APSA UP Chair of Data Science and co-founded, as David said, Deep Learning Indaba and Masakane over there. Just in terms of my path, especially in data science, one was while I was at the CSR thinking about data science for social good, which means like, you're really looking at societal problems that are out there, then figuring out some of the data science aspects that need to be dealt with. Sometimes it's just the data, sometimes it's modeling that happens in there, and sometimes it's building tools that other people can use that are data driven. So at CSR, which is working with a lot of government departments to harness data for decision making, and then also training future data scientists through the DSIDE program and also deep learning in Indaba. At UP, as I said, I started this research group, and I work on research and teaching within the data science space and also in natural language processing specifically. So my research group actually does now about 70% of the work in natural language processing. One of the interesting projects we work on, I won't talk about today, was on building an open repository for COVID-19 data for South Africa. That's really gone on and being used by many people within this space. So our group is full of a lot of young researchers who are working to really tackle very interesting problems within many spaces. So I know that within, I think I've seen some of the workshops in the past for CoE-MaSS. I thought that I should just focus on, hey, let's look at natural language processing, then let's look at some data science problems within this space. So to really do some justice to that, I wanted first to, let's think about language and how it's connected to artificial intelligence and machine learning on one. So one thing is that text and language is a very rich interface to share information and interact with machines, right? There's things that we've gotten used to as humans where you can see things, sure, you can absorb a lot of information, but then when we are really working to share ideas, to communicate and really build on knowledge, a lot of it is really through language, right? Whether it's written or it's spoken on there. So there are a few questions then you have to ask yourself within these spaces or within all these sensor, the sensors that you have to use. And one is how do machines process language information? And then also what are the challenges that we might face with local language on them? So one, language and NLP allows us to understand our world. It allows us to communicate, and then we spread ideas as well. At the same time, we have a very large language diversity. The African continent is one the most diverse in terms of the amount of languages that are available, and with also different families of languages that you can then find spread out throughout the continent on there. And then if you break it up, to the rest of the world, there's a lot of diversity within that space. So just to ground it in terms of, hey, this is not something that's far. Natural language processing itself is a broad field and it encompasses a lot of tasks. So there's things like parts of speech tagging in documents where you're identifying nouns, verbs, adjectives, name entity recognition, identifying person names, organizations, locations, etc. So I think there was some recent work for example, on doing things like this on court documents where you can identify who's mentioned with who, what organizations are connected to what, or which people on court documents. There's question answering, speech recognition, text to speech, speech to text, topic modeling, sentiment classification, language modeling, translation. So I like, for most of you, this is likely some of the things that you've interacted with in the past in one way or another. As I said, like I don't think I'm going to go too deep into just the application spaces, but at least I'm giving that overview. Breakthroughs that you probably use every day, things like search engines. Now we have these virtual assistants that you can interact with. You can ask questions, and they keep on getting better and better on there. Things like chatbots, where now you're not really sure, especially when you're online. Am I interacting with a human when chatting via text, or it might just be a machine? Things like translation systems, and then probably one of the first places almost like most of us interacted with something that was using machine learning NLP was inside your email, the spam filter, right? Because it learns over time. It's reading the text and then coming up and with those labels on there. So I wanted to talk through some of our work in this area as a way then to look at some very interesting problems that we can look at through natural language processing, but which are really impactful from a data science perspective. So this one is some work we did, started about 2 years ago and then finalized last year, even though it's continuing to evolve with other collaborations. So the name, like the paper was, Is It Fake? News Disinformation Detection on South African news websites. This work was done by an honor student here at the University of Pretoria, and I was the supervisor and also helping shape a lot of the work here. You see? All right, so what we wanted to do here is to let's look at this information, but from a localized context. So some of the things maybe to note at this time, and maybe I don't have a slide for that, I should have put it in, is, for example, if you think about a company like Facebook, they have over the last few years been faced with a huge challenge of disinformation and misinformation campaigns. So what they need to do is have systems that can then identify when somebody shares something on there if it might be suspicious of a misinformation, disinformation campaign. What you would have seen, especially in the last 2 years or so, is that when it came to things like vaccines, they would start popping up and saying, oh, this has to do with COVID-19, and for your country, this is likely a place to get proper information. The reason that they did that is to really fight against people who might be providing information that is false. On that part. But sure, that's something that was public and we all knew about, and we'll try to fight against. But there's also a very veiled ways that people try to spread misinformation and disinformation, right? So misinformation basically is, hey, you don't know that the thing is not correct, and then you send it, you share it, you continue sharing it. Disinformation is that you actively know that the thing that you're sharing isn't correct, but then you're doing it for different reasons. So some people, for example, create websites where they know they're very politically charged in one way or another. So if you're thinking you might be one party versus the next, and a lot of them do for both. So it might be pro one party, anti another one, pro the other party, anti the other one as well. And what they do is they create sensational kind of headlines on the point that you will click and go to that website. And what they do is they earn money through advertising, right? So that's maybe oh, okay, that's why they're doing this. But then we've seen also in how the election, especially when it was Donald Trump versus Hillary Clinton, it was identified that Facebook was actually used to change the behavior of people and getting them to vote one way or another. So you need to then build tools within these systems to be able to identify these things. But Facebook only spends 13% of their what will be like an abuse budget, so things that are supposed to be looking for abuse on their website. So if for whatever, if they had 100 rand that they were using to battle misinformation, disinformation on their website, only 13 rand is used for any of these misinformation and disinformation fighting that is outside the US or Canada and not in English. So you can kind of see how this might be a challenge for them to actually identify really on there. So we are working within the space of saying, okay, how do we then check if there's actually a different context if you're looking at South African misinformation or disinformation websites and seeing if you just use a model that came from American data if it will work, right? So what we did is now we created a South African disinformation data set, looked at then building up also some observational things about behavior. So where we got this is we had 3 data sets that we used. So one for the South African one, it had 807 disinformation. This list came from My Broadband, which is a techie news site and has forums, and then News 24. And then with that, they had, at the time, like a blacklist of websites. And then from there, we used Internet Archive to go and extract all of these articles. We then also found a data set that comes from Kaggle that was American labeled data sets of misinformation and disinformation websites, right? So what we did from there is that you can then do different things. So you can build models, natural language that process the text, and then from there, they come up with the representation. You put this representation through a classification algorithm, whether something is actually misinformation or not, right, on there. So we want to do the classification of this information, do the stylistic understanding, and then get to a point where we can make some of these results interpretable. And then interpretable is that you can go inside the model and see, oh, if something is not misinformation, not in misinformation, what are the words that might have added to that? And then if it is misinformation, what was actually going on within that? But then I think of importance from what I said at the beginning is looking at what happens now when you've got the data, you built these models, and then you see how well they work on different things. So let's say now you have a US data set that we do training on it, and then we test on another US subset 2 of that data set. So you can see that the accuracy and the F1 scores are very high on there, on that. In the same way though, let's look at South African subset, and you can see you're getting 82% accuracy within that space. And this is just general without actually doing any balancing of the data, because there is you always have more data that is just benign as opposed to being fake or misinformation. Then there is when we balance the classes, and then we look at different other items to just increase these performances on there. For you to really look at now is then thinking about, okay, what happens now when you train a model on the South African subset and then test on the US? You can see now your accuracy jumps to 50%. So any article, you don't really know what could really be going on. And in the same way, if you're using a US subset and then you test it on the South African subset, you're getting up to 65% accuracy within the space. This is very important to have because it does have implications that now if these systems are mostly, let's say, because now you're not having a lot of teams that are checking for these websites that are actually shared and then marking them, you might go for an auto system where it's like, if enough people report, then we will kick off that link, or we will ban the user for 24 hours or something like that. Something very rudimentary, which is used as a heuristic, but might not catch that people will create thousands of these websites just to get you and then to click and then go there, or to see it as an ad on whatever platform that you're using on that part. And again, if we're not having a lot of people actually looking at our countries and our languages especially, then that context is lost. And second, very harmful material might end up in different spaces. I think there's work like, looking at what's happening in Ethiopia, and that some of that is actually driven by also these social media campaigns that people are creating on that part. So there is this requirement that governments, especially, as I said, outside the US and Canada, should really be demanding more within these spaces. When we, so that's one thing we could look at on this one. There's more work that we're doing in these spaces, especially on finding ways that we can figure out what the models will do without yet having to train the models, just by looking at the data on them. And when we did do a combined model, so if you see here, where it's SA and the US one, you are starting to get a performance that's actually getting you back to that 90% accuracy, and a good F1 score as well on that part. The other thing is that we can look at using different methodologies to do interpretable machine learning, where now you can identify the words that really are connected with the labels being fake, not fake. Misinformation, disinformation. We work with journalists sometimes. They don't like us using the word fake news, so we try to keep to misinformation and disinformation. But what we find with a lot of these things, especially in South Africa, is that there's a lot of racially charged and very emotive language that is used in these websites to get people, again, to either click or to obviously push up an agenda, right? So in the South African one, you see very emotive language that is used within these spaces, and you can identify from these different articles what's actually going on, right? So you can then think about this, that you might have these systems that are working in tandem with humans. So the system identifies something going wrong, which is what happens in these companies, and then sends it for human review. And with interpretive machine learning, you can highlight which parts actually of the content might be actually suspicious on that part. What then we did do is that the data set has been released. It's available online, where you can download it, and we're very interested to see also what other people come up with, and you can read the paper also to find where the Kaggle and other misinformation data sets, these big international ones, actually are to compare. So that was one. Now, switching to a different thing, one of the things that's been very interesting, I guess, being in data science and natural language processing, is how many times one gets these emails asking, hey, I would like to do a master's or a PhD, but I'm interested in connecting social media analysis with predicting the stock market. So for me, it might not be that interesting to look at things in that way, but there was one time we were talking to a student, in this case, Michelle, at her lunch. She was a master's student here at the University of Pretoria, and we were thinking about, okay, what actually does happen to stock prices when very big negative events actually happen on part. And then this is the work now on looking at can we build financial sentiment analysis, and looking at it from a South African view again within the spaces. So in this, in looking at this problem, one part was looking at it from a perspective of reputation management, right? So there's many different organizations that try to do this, one being this RepTrack score that takes into account drivers of reputation for each organization, and using different sources to come up with these scores. So you can take your textual information, what you're doing is communication strategy, connecting it to your market perceptions, and then you've got a reputation, right? So on one side, on the performance side, you've got your accounting information, and then you can use some statistical models and machine learning, and then you're trying to connect that to the textual analysis to predict this performance, right? So is there a financial value to reputation, right? So if you improve your reputation, improving the reputation can increase the company bottom line, plus minus 6%. So this is a performance driver. Determine the sentiment of finance-related communication and its impact on that performance. Oh, okay. There's lack of research, it seems, yeah, when I copied this in here, I think it's stressed a bit, sorry about that, on NLP financial sentiment analysis on the South African continent. This is the gap then in this research that we wanted to look at. And then the existing sentiment analyzers, hopefully now you're getting it, they are available, they are relevant for specific domain areas and geographical areas. So what you might find is that something that you can easily download is trained in American English or like UK English, given that input that people labeled data that comes from there, but might not work very well or be precise for South African data. Right, so what NLP techniques are required to successfully determine the sentiment for financial communication, and is there a correlation then between the financial news and company performance in terms of the share price? So remember I said at the beginning about this thing of predicting stock market. And then how can we narrow our sentiment prediction model be applied to a broader group of finance related information? So I did talk about this. There are many open source pre-trained sentiment analyzers. One big one you'll find if you use Python, you can just quickly install text blob or Ada. You can use simple dictionary-based approaches. So what this means is that you come up with lists of positive words and negative words. So there's this one called I think it's Logran McDonald sentiment word lists that are specifically used for finance on there. So they have negative, positive, uncertainty, weak modal, strong modal, litigious, and constraining classes, and then they put these words or phrases within there. Another way you can do it is that you can go out there, get data, label it yourself, and then build custom-built, like predictive models. There's traditional kind of machine learning with traditional NLP, and then you can also do deep learning models, right? For do this, you need labeled data on there. There is some data sets that are out there, might not, again, be collecting any South African data. And this one was like, on semi-val competition, was analysis on financial microblogs on that part, right? And with that work on the semi-val, there's all, because it's a competition, you also then are able to see like different performances on there, where you saw a one-dimensional convolutional neural network with embeddings from GLAB, which are also general embeddings. I think they come from like a big web crawl of the internet for these embeddings on that part. And you can see here LSTMs are second, then the support vector regression on there, and then support vector regression that's still also giving you these scores there. So just on a showing how the sausage is made in here, you would go in, collect your data, clean it, do some topic modeling, so remove things that might not actually have to do with finance, but you think were connected to finance beforehand, annotate that data to get some ground truth, build a model on the document titles, and then see, hey, does this actually correlate with financial performance? So, hey, when things are very positive that you're seeing out there, doesn't mean that the performance financially is going up. And if they're very negative in the news, do they go down? And then you also want to test for things like generalization. So we went on and got data for 7,666 online news articles, as well as SENS reports from the JSC. We then did topic modeling for all of this data with NMF, non-negative matrix factorization. With those documents, we labeled 808 of them. That's the breakdown just from positive, negative, and neutral. So a lot of negative articles, and then built that model. So in terms of the approaches and results, pre-trained analyzers, right? Accuracy for text blob was about 19%. So now we're testing it. We've come up with ground truth for that data, 19% accuracy with text blob, Veda 51%. Built a XGBoost model with TF-IDF vectors. There's the validation of 80-20 and then tenfold CV cross-validation. And then the accuracy is now up to 81%. And then, as like in the same way with XGBoost, you can check which are the main features that seem to sway you from one class or category to another. So rebound, rally, firm, firmer, warm, resilient, higher. You can see kind of these words, and then we can get up to like 94, like, a good accuracy when you look at the full data set. The other one then was to do this lexicon-based way. Can we come up with a dictionary, an updated dictionary that works better with South African financial speak, basically? So we had a base dictionary from that first data set we talked about, the McDonald one, and then we added synonyms, and then, like, without these, but then doing, like, not adding synonyms, but doing manual addition or deletion within the space. So looking at the headlines and then seeing which words have to be added and which ones have to be removed, right? Yeah, so you could have hinges, things like as, but, amid, after, ahead, while, despite, is here, right? On there, so where hinge word wasn't present, use the comma alternative to the full headline. We use lemmatization. In the case where multiple sentiment carrying words were present, the first occurring positive or negative word was used. This is, again, a heuristic. There might be better ways to do this, but we wanted to check. And where there was no match, it was labeled as not detected, and you can remove that, right? So on those things that you could have a negative, and then you have a hinge word. You have JSE closes firm as rand slides. On there, there's a hinge, but then you will take that first bit on there. So with the lexicon-based one, with the different experiments, we went 30% accuracy at the beginning, went to 67% where you added synonyms, and then went up to 84% where now we did additions and deletions of new words and phrases given our new dictionary. So, sorry, that's just stuff that's right. Yeah, so with the new dictionary, it was increased and removed break, close, closing, and despite within the spaces. So in this case, the traditional machine learning model performs better in the set, but remember, one of the things that's very good about building up a dictionary is that now you have something that's human interpretable that allows you to get close and can allow for better analysis also in the future on there. Now, on the correlation with performance, here we just get, we couldn't get there's deeper into this during the master's program, but it's still open for more work in the future, where now we look at the performance of the stock price and then look at now these lines here are either a story that came out and whether we classified it as being negative or positive. And you can see, like, in some of these, there's this changes, the stock price falls a lot, and there's a lot of writing that's happening there that's negative on there. So there are correlations. We're not talking anything about causation, and that will still have to be tested. Then what we did is also then looked at, okay, so this is from one company, I think a big company in the JSE. Then we looked at, okay, fine, if we build a model for one company, can we do it for another one that is very similar also in the energy sector? Same area in terms of time, filtering of data just to only have data that has to do with financial related topics. And then we use this updated dictionary and then this previous classifier kind of on there. Here's your new data set on that part. XGBoost was biased towards more negative. There was some agreement half the time in this space, and then a dictionary-based one seemed to then generalize a little bit better. It's better. Only 29% of words exist in pre-trained vocabulary on here, and there's still work to be done maybe to improve that generalization. We weren't using word embeddings, and I think that could have been one of the things to do better. Then you can look in the same way at this other dictionary-based way, and then we look at the share price movement of this other one. And then you see how it's moved. Obviously here, like, if you think about the 2020, very short crash when we started having lockdowns on there, but you could then see that still there was now news articles that were coming out on there. So we were able to then use NLP techniques in these spaces. It is positive in terms of some of the correlations that are on there. And with refinement, it might be very interesting to use it to kind of understand some of these risky periods that might happen. If that, for some people, they think they can profit off, it's on there, but Can it generalize? The dictionary-based ones, as seems to be a little bit better on this one, but there's more that can be done, especially now we have these transformer models that can really capture, especially phrases in context that might work on that, right? And then there's still some work to increase the data set. We have then released also now this data set. You can get this LMSA 2020 data set, which is now this new dictionary lexicon for finance, but then with other terms that are added for the South African context, and we hope people will be able to expand on it on there. So as we said, we're setting the foundation for expanding in this area and then seeing what else can be done. We are still continuing with this. There's some work for bank risk. That's a kind of slightly different approach on looking at bank failure in South Africa using NLP as NLP pipeline. Future work is more sophisticated, streamlined processes for updating these lexicons, improving model generalization, and then being able to publish open source tools that other people then can use. So with that, what have we done? We've looked at now something again that for society on the side of disinformation and misinformation. We looked at financial sentiment analysis and what that requires, by then adding more kind of figuring out what actually works best in the spaces. The last one I wanted to talk to is then, hey, when we want to deal with data that comes especially from local languages, typically you don't have a lot of data. So if you're building models in this space, they're very sparse. What can you do within that space? So this is some work that was done with Chabisa Safara at the CSR. So what data augmentation? So I'll use images as an example. It's a strategy that enables you to increase your data set size syntactically. So in computer vision, for example, what you could do is you take an image and you create 6 other images by doing flipping, rotating, cropping, jittering and enhancement, and then maybe doing some PCA on there. There's lots of stuff that you can do on there. You might even take one image and then it multiplies by a factor of 20. And also at the same time, it actually increases your robustness of your model, right? Because it doesn't mean that you're just looking at an image just like this and say, oh yeah, there's a fighter jet in there. But by doing all of these things, it allows that the model that you're building will be more robust to any slight changes in images in the kind of in the future, right? Data augmentation at this time for language processing is still is encouraged, and there was when we were working on this in 2019 and 2018, there were a few approaches, but then I think now in 2022 there's more, and there's more work we've done on this. But then at that time we were trying to think about, okay, but then what happens when you're thinking about this in low resource scenarios? Our contributions here is looking at a few of these approaches from a global view. So meaning we're not looking contextually, we're looking at what's in the words in a sentence as opposed to what might be happening in terms of the sequence. We look at what methods that use linguistic features, and then also methods that can then act on embeddings or representations in the models. In the work. And then from there, one of the things we did, I think one of the first papers to show the effect of the mix-up method on as a model for augmentation that acts on the representation of the words as opposed to the words themselves on that part. So you can use data augmentation as regularization. As I said, it gives you that robustness on there. So these were the 4 methods. We were interested in what happens, especially when you reduce the size of your training data on that part. So one was coming up with synonyms from WordNet, words from Word2Vec, round-trip translation, and mix-up. I'll talk a little bit about that. But then what you need to know is that the first 3 act on the text source, and then the 4th one works on the representation of the words. Are they linguistic? Yes. The first 3 do not act on the labels, they just act on the input. And then do you have some semantic information? Yes, for the first 3, the last one, it does not know. So here's a simple one And there, so you've got, for example, in the, let's start with the WordNet one. With the WordNet, you have things like synonyms. If you have a WordNet for your language, and it does have parts of that WordNet having synonyms. So you can have, in the afternoon, John is going to town. It identifies, hey, John is a noun, going is a verb, and then there's some probability that you're going to replace a few of the words in there. You can choose and say only replace verbs, only replace noun, or replace both, given some probability. So it takes the word John and then just checks on what's a word that like similar to John, Joseph, and then going, change it to walking on that part. So that's one of like a synonym-based replacement, but you need to have basically a thesaurus to be able to do that. That might not be necessarily possible for many languages out there, that they don't have these digital synonym or thesauri that they can use on them. The other one is round-trip translation. So let's say you've got English, you have an English to Xitsonga model, which now, for example, Google Translate has. What you do is you put this into the English to Xitsonga translator, and then you do a Xitsonga, take the same result and put it through a Xitsonga to English translation model to do that. So you can put that in there, and then it pops out the same sentence, but now John is going to town in the afternoon, just because you've done that round trip translation. There is a cost to doing this. It's fine if you're doing, like, you're translating a short sentence on Google, IBM, Microsoft, or Amazon, but then once you then get into, hey, I have 1 million sentences, actually you will have to pay for those translations from these services. The other one is using Word2Vec. So Word2Vec allows you to build semantic relations between words. So whether you can take data from a language, so just written data, train these Word2Vec vectorizers. Once you've done that, what they give you is the thing that you should get if you've got enough representative data. You should then be able to get which words are close, similar to which words using Word2Vec. And with that, the reason we wanted to look at that was, now, if you are in a low resource language, you don't necessarily need to have a WordNet that is complete. You can just take as much documents that are out there in that language, train Word2Vec models, and then it will take, like, the stories are good, choose a word to replace, and then just replace it with what's probabilistically a similar word to the word story. So here it will just replace it as the films are good on there, right? So we've kind of talked about this. I'm not going to, so we've done the synonyms through WordNet, which is a lexical database on there. Not all of them have the the thesauri that's available, but for English, it's there on that part. The semantic similarity using Word2Vec, word embeddings, you can use Word2Vec, Lab, Patek, there's all these on there, and you can use them through this Python library called Jensen. And then round-trip translation, as I said, you could use these services and pay for them, or you could download a model that's pre-trained and then you can run it on your own computer. It's just that you should have a computer that allows you to do inference very quickly on that part. We were using Amazon Translate and we paid for it from that. So, and then the augmentation on representation, we use Mixup, and Mixup can take any, as long as you have a vector, it will act on it. And it acts on both the input and the output. It's data agnostic. It's applied to images, speech, tabular data. It creates a new training example by drawing from samples. So it will take 2 samples from the original data set and find ways to combine them convexly to create a new data set. The data that we had in this time was English data. There was a sentiment 140 data set, which is short text, and then has sentiment labels. AG News, which is more the traditional news in English, that is more formal, and then a hate speech data set, and you can see the different types of, it's a binary classification or categorical, more than two sets. We tried logistic regression as well as a deep learning model, which is basically an LSTM with a convolutional layers on there. So one, we reduced the data set sizes. You could see they were large on there to to about 10,000 size just for training, and another validation 10,000. So we would sample just a random 10,000 from those large data sets. If you look at the AG News one, which is news, which is much more formal, I'll be wrapping up now. you can see as the epochs of training go along, if you're not doing any augmentation, you start overfitting, right? Your error goes down and then it goes up. You put in mix up, you get a bit of a benefit on there. So if you're just, then once we started putting in things like synonym replacement, your performance gets a bit better with mix up also. And then with that round trip translation for the AGUs, this is logistic regression. For the deep neural nets, it's the same way. You like no augmentation, you're going to overfit faster. And the one that we saw that was very interesting with this one, you could do synonyms as well as round trip translation. And with mix-up, that's when the deep neural net wasn't really overfitting as much. But the thing that was very interesting to us was also the performance of this word-to-vec performance on keeping that. So to see here, formal AGUs on this part, doing mix-up is giving you a good boost. You can use these other methods for augmentation, and you're still doing well. Number of augmentations. Should I augment 1,000 times, 10,000 times? Depending on that, you do get a boost in. So here you've augmented more, and and then you see the error is less over that period. So 10,000 times on there. This is for AG News for the sentiment. For the sentiment 140, you can see in the same way. If you do now word to vec multiply by 5 versus multiply by 10, there is a difference on there. Now, especially at the beginning in terms of how fast you actually drop off. Effective augmentation and overfitting, if you've got the deep neural network and the sentiment 140, what you want to do is you want this change to be as late as possible, really on here. And what you see here again is the synonym mix-up and the word to vec mix-up on the sentiment 140 were the ones that really kept to being later. And then for the AG News one, where it's more formal formal writing, mix-up really keeps us going for further. So you can see that if you now have the traditional replacing things on the words, word level plus mix-up, you really can have your models actually train for longer and better. So for us, the reason we were doing this is that we were now setting up a foundation for working on more African languages and seeing, even if we don't have enough data, can we come up with training regimes that allow us to really exploit augmentation for these languages, even though we don't have WordNet, might not be able to use round-trip translation because it's expensive to use these models one way or another, whether you're paying or you're going to have to have a model that does good inference, but you can build these things on there. So for us, we think that unsupervised word embeddings are a viable way to try out, and then add in mix-up really as a regularization method that really gives you that extra boost on there, right? So even on AG News, which is the more formal one, word to vec based augmentation is competitive. Round trip translation, it's expensive. I think we might have spent something like $2,000 to $3,000 in credits from Amazon to do the round trip translation. So we did it for this experiment to show what's going on, but then for academic work, I think it is also it would be very hard sometimes to be able to justify that if you're not making money out of there's no money that's coming in for that. What we did do with this one, we did release a library called Text Augment that you can do a pip install Text Augment if you're using Python. And I think at the moment it's over 80,000 downloads, and then it's nearing something like 5,000 downloads a month. And it also has more and more augmentation methods that have been added in, and we've also taken some of the methods that we tried out and put them in. There's another NLP augmentation library called NL Augmenta, which we've contributed to, which has, I don't know, I think something like 50 augmentations now. So as I said, this was this is work from 2018 to 2020. There's newer work from 2021 and 2022 now that has brought in a lot of large research projects with different groups working on these spaces. So I think I'm going to stop there. Thank you. Thanks for this. I just wanted to maybe leave this for some questions and any comments and concerns.
Thanks very much, Vukosi, and for keeping us up to date with the latest developments in the field. I'd like to get the question session on the go by asking you that I've noticed in Google, for example, Google Translate in recent years, well, fairly recent, that a number of the official languages of South Africa have come on board into the translation language set available. Is that largely a result of this kind of research that you've been doing?
Yeah, that's a good question. Yeah, there's been, okay, so I didn't talk much about Masakane just because of the time. So with people like with the Masakane project, there's been many sub-projects through things like the Lacuna Fund to create data sets. That's on one side. To also collaborations to work in very large distributed teams to try out lots of different things, but then for African languages. So I think with the Google Translate model, if I remember that paper, when they released it, they were doing things like transfer learning. So if you have many languages, you don't have very large data sets, but that they might be related across the like different continents. What you can do is learn about one language in terms of what's going on in translation, and then transfer some of that knowledge with a small data set to another language on that part. So transfer learning has also become feasible. Sure, people like Google have many large compute clusters that they can use that maybe might not be possible from a research perspective right now for like small research teams. But there are also, I think there's a new model that came out of the Big Science Project. I'll put some links in, Bloom, which was released about a week or a week and a half ago. That was this project where lots of researchers from all over the world worked together, got a grant from, I think, the French supercomputing center, and then were able to train a completely open source model, which is like, you know, obviously going different to Google will not release their model. It's a competitive advantage on that part. But yes, there's a lot of these things that are going on.
Thanks very much.
Yeah.
I'd like to open the floor now to those of you who are online on Zoom. What questions do we have from you? Anyone want to start? Questions? Get the questions going.
Hi, I have a question.
Oh, hi.
Great, carry on. Go ahead.
Hi, I'm actually not from a data science background. I'm in the Wits School of Accountancy, but we've been using natural language processing to identify sentiment in for purposes of impression management. And what we've been using is BERT, which has been trained further using financial text.
Yeah.
And I was just wondering, with your study on sentiment analysis, we found it to be very accurate. So with your study on sentiment analysis, is there a reason why you chose not to use BERT? Or I know BERT only was developed in 2018. Was it just not around at the time, or was there another reason?
Yeah, so one was availability of pre-trained BERT, I think, when the student was starting their project. And then we also wanted just like, it's always worth like in this specific area, we're also interested in what happens if you use more traditional approaches and trying to compare them to things like lexicon based. So what we tend to do is like I use that rule that like start with the dumbest thing first and then build on as you do. So we do have other projects where now you're using BERT fine tuning and then seeing how well kind of that works, but you might lose that interpretability of what's actually going on under the hood. Hopefully that answers your question.
Yes, thank you.
Yeah, but we would be very happy to see how well, getting into more interesting spaces in this area. But we are like, I think there should be some work on just doing some data analysis. So looking at the data, not even training the models, and seeing what actually might happen if if you train the models later. So it will tell you something about what likely BERT is doing also as well. But that should be out later in the year.
Okay, thanks. Who would like to ask the next question? Do we have any on the mic or on the chat window? Okay, well, I'll ask another question in the interim.
Sure.
So just from personal experience, working on these automated call centers when I was in overseas countries, the issue of accent is I found very problematic. Now, you mentioned the whole issue around disinformation. US and SA data sets were not interchangeable. They produce completely different results. So are there ways of handling foreign accents in a country where there's a mainstream accent like a Canadian or American or French, and then you come from another country and introduce a different accent which is not generally recognized?
Yeah, I don't think I can talk directly on that because like in all the work we've done probably over the last 5 years, I've been only involved in one project for speech, and then it was really working on speech to text and then translation. But what I do know, there's things like Web to Vec that look at now doing embeddings on the speech level, and with that, I'm expecting that with enough data to train those, if you're doing things like transcription, they get better and better. I do know a lot of the dominant approaches in general are likely localized. So you might build a model for Southern Africa in terms of how people speak English, and then put it inside a call center just to transcribe the conversation, and then do one for the United, like, you know, the North America, another one for the United Kingdom, and different one for the rest of like Europe or something like that. But you can likely see that changing over time. And how do I kind of think about that heuristic that it's working? I've played around with a lot of the what are these things, the virtual assistants over time, and they've improved. If I go back like to the first release of Google Assistant, what was it called then? Google Now. And then you're just talking to your phone. It was like, yeah, I was South African with a South African accent. I was living in the US at the time. And there were things it wasn't getting correct. But then right now, like fast forward, how many, almost like 7 years later, it's much better, and the error rate has gone down a lot on that part. One is that all these companies are also collecting, obviously, those voice recordings, getting people to check them and annotate them further, and then building better transcribers.
Okay, so continual work in progress.
Yeah. It's basically, if you've got the time, you can keep on building your data sets better.
Are there any other questions from the online group from Zoom? So if there are no more questions, then Vukosi, if you just want to talk a bit on the project.
Yeah. So in this one is like, okay, so one of the things we kind of identified, one with the deep learning Indaba, was the part of, if we look like across not just South Africa, but the African continent, it's very hard to get to a point where I think where we realistically are going to get to computer science department or engineering departments that have 100 PhD students and who are all working and bumping into each other every day in that one department, let alone sometimes faculties. So we need to think about how we do research with each other in a very different way. So one was thinking about this thing of grassroots AI and how it's actually has an unreasonable effectiveness in doing collaborative research. So what are grassroots AI movements? You want to lower barriers to entry, multidisciplinary, they're very inclusive, coming from a different base to maybe different from what industry typically does, what academia typically does. They try to address systemic issues, collaborative, independent of institutions, very multi-institutional, holistic, and really community focus on building the community and keeping it healthy. So if we go back over time, thinking about things like CERN, the Santa Fe Institute, and then once AI and machine learning became very viable in lots of different places, you see the emergence of things like women in machine learning, Black in AI in the 2016, deep learning Indaba in 2016, and Data Science Africa as well, starting off on that part. Masakani is a spin-off that comes from the Indaba community, and through that Masakani also, you then start seeing things like North Africans in NLP, America's NLP, that are looking at, you have these other models that can work across different organizations, regions, and then working together. So Masakane is a grassroots organization, and the mission is to strengthen and spur NLP research on African languages. Masakane itself translates to we build together. The community is now over 1,000 participants over many, many African countries and even beyond. Lots of languages that are covered in lots of different NLP tasks over the period, and there's many publications that have come on since 2019 in this space. The partner institutions and labs across the continent and also in other continents as well that have come in just to act as a foundation that allows Masakane to do its job. But even now, the thing that has changed, especially I think over the last year, is Masakane itself has become a proper registered organization that works on there. There have been now 3 workshops. There was the first workshop at ICLR 2020, EACL last year, and actually there was a second ICLR workshop this year for ICLR 2022. The first major paper to come out of this distributed research approach was the paper of participatory research that really showed working on creating 47 translation models for 35 African languages, and these are available on there. And this paper actually won the first Wikimedia Research Award that they had for the inaugural one as a joint winner for democratizing the internet on there. And how is Masakane different? It works on having everybody in the pipeline. So the people who create the content, the people who annotate it, the curators, the language technologists and evaluators working together to create new content, annotate the content, create data sets, build the AI model, get feedback, and then figure out how to actually improve these processes. So you find that people meet, I think, every Thursday night. You can go to masakane.io and you can join the Slack every Thursday at 7 p.m. South African time. There's a meeting. People talk about the projects that they're working on. And then, yeah, people just jump onto a project and start working together. And then we see over time what actually then happens. And through this, a lot of the Masakane community have been able not just to submit and get their work accepted at some of the biggest and top venues in natural language processing and AI, but then also create a more localized community that then sustains itself over the period. So yeah, that was it about Masakane. As I said, you can go to masakane.io. I'll put the link in, just to give that context of how, some of these models that you're seeing right now are showing up on there. So even in the blue model, there's a number of data sets that we use inside the blue model that come from Masakane and even our lab as well.
Thanks very much, Professor. That was a really interesting talk.